Yeah, Mo here. Let me show you something. This vehicle is going to be run by a V-belt. The V-belt will go between the motor and the transmission. Well, there has to be a belt tightener of some type. So what I've done is I've come up with a situation here where this is a carrier for the idler. And if you look real close, you can see that there's green tape on here. Well, that's because I'm going to powder coat this thing later on today. But what would happen is this idler would drop over this stud with that nut on the top, and it would push the belt tight. And the way it does that, well, the powder coating's done. I showed you that. This is the gear shift lever, and it's kind of a cool color. It's not flat black, it's called caveman black. Okay? Here's the belt tightener. I showed it to you before. The green tape went right here, and that's what kept the powder coating off from the feature of this. There's the idler. The belt comes around like this, and then there's a spring that pulls this way and keeps the belt tight. This is what holds the whole thing into position. It sits underneath by the motor. This slides into those grooves. You can see the grooves there. They're called dovetails, actually, to a certain extent. This goes in like that. There's a spring that hooks on right here, and it pulls it this way, and the belt comes around this way, so as it pulls on it, it keeps the belt tight. This will make the whole thing simpler. You don't have to adjust it with the spring. It's an automatic adjustment situation. As the belt stretches, the spring will take up the difference. Okay, here's what I'm trying to accomplish. This engine that's going to be in this parade vehicle is a twin-cylinder engine. And I don't want to have to run double exhaust all the way out the back of the vehicle. So I wanted to pair them, pull them together. Well, in order to do that, first thing I had to do was make this thing. What this amounted to was a couple of pieces of round stock. I cut them at a 10-degree angle, welded them together, buffed the ends so they had a taper to them. And then I went over to the hydraulic press with a piece of tubing very similar to this, and pressed it on. And what that amounted to is now it gives me the opportunity to run 2 into 1. This is a piece of stainless steel that I had. What will happen is this will get turned with a 90 degree, and I have to lengthen one of these because of the spacing between the cylinders. I actually have to cut both of them at that location and turn them so they all end up in the same location. Anyway, I'm going to have to take the motor, put it upside down, put this stuff on, make some cuts in it, do some tacking and messing around, but when I get done, I will have 2 into 1 with a stainless collector, and we'll take and run this diameter tubing, which is 1.5 inches. I'll run that out the back until I get about a foot or 10 inches, 12 inches, whatever, from the end, and then I'm going to bump this up to a 2.5 inch piece of stainless. What I'm after here is trying to get the sound of a twin cylinder. It's going to be, it'll be a drawn out process, but when I get done, it'll be worthwhile. What I'm doing here is I'm doing a chamfer on the inside, so it'll slide over the top of the tubing that I'm going to use for the exhaust. This will be in the splice area. It'll give it a little bit more rigidity, and it'll be a lot easier to weld and a lot easier to set up. This is an old lathe I bought many years ago. And all we use it for is what you see right here. A little chamfering once in a while, a little buffing once in a while, deburring. No sense tying up a more expensive lathe just to do these little operations. As you can see, it's pretty efficient. The guy bought this lathe, it was in a chicken coop. And it was covered with things the chicken gets rid of, and I'm not talking about eggs. Okay? And I took a power washer, and it took 30 minutes to get the metal. It was that covered. I tore it completely down, painted, put new gears in it where it needed it, put a new motor on it, converted it to variable speed, as you can see. So it makes it a pretty versatile lathe. I call this one my chicken lathe. As you can see, I've got the exhaust kind of put together. It isn't welded or anything. There's some places tacked. Here's that piece that I showed before, and we have 2 exhausts here. If you look close, you can see we've got 2. And this form, it goes on like so. Now what's going to happen is it's going to be cut off about right here, and there'll be a 90 degree like this, and it will hook into a connector that has flexibility to it, but it doesn't leak, and then it'll go continue on and go out the back of the vehicle. I spent 3 hours on this afternoon, and I'm very pleased with the way it turned out. Each one of these are a little slip joint I made. There's a slip, there's one right here, as you can see. That's the easy way to do the thing, because then you can adjust, you can move things around and get them just exactly the way you want them. If you just butt the tube together and tack it, that's a disaster. I know I've done it before and resorted to doing it this way, and it just works a lot better.